Hi everyone, my name is Sean Moriarty and I am the creator of Axon, a library for creating and training neural networks in Elixir, and that's actually the subject of this talk. I don't think my slides are up yet, but we'll get there. This is my first ElixirConf. Is it anybody else's first ElixirConf? Yeah, so first ElixirConf, first talk, excited to be here. And I'm here to talk to you today about Axon. So there we go. Oh, it's got my presenter view. It's embarrassing. Okay, I guess I'm going off of notes. Does anybody know how I full screen this? F11. There we go. Okay, so the subject of this talk is Axon. Before I start, I have to give a little bit of a disclaimer. So the views expressed in this presentation are those of the speaker and do not represent the views of the United States government, the Department of Defense, or Army Cyber. A little bit about myself. So I've been programming in Elixir for about 5 years now. I picked it up my sophomore year of college. I actually found it on an answer in Quora before Quora turned into all junk and went the way of Yahoo Answers. My primary interests were machine learning, evolutionary algorithms, mathematics, which were all the things that you couldn't do in Elixir at the time. But I loved the language so much that I kind of decided that I was going to do it anyway. And I started messing around with genetic algorithms in Elixir, not with the intent to really go anywhere with it, just to try something new. And I thought, oh, this is kind of cool. Maybe someone else will like this. And so I decided that I was going to try to write the book that literally nobody asked for, genetic algorithms in Elixir. And from there, we went on, and that kind of sparked the creation of NX and EXLA. So does anybody know what NX and EXLA are? Yep, so numerical Elixir, and then EXLA is a JIT compiler for NX, and we'll talk about that through this presentation. As NX and EXLA have stabilized and matured, most of my time now is focused on Axon, which is a library for deep learning. I call myself a machine learning enthusiast, so I'm not really formally trained in machine learning, but I'm really obsessed with understanding how things work. So when I was working on EXLA, I would literally go to bed, like reading the TensorFlow source code, trying to figure out how it worked inside. And a lot of this talk is me distilling some of the information I learned through my research down to you all. So the subject of this talk, there's really three main takeaways from this talk, or questions I'm trying to answer. The first one is, what is Axon? Why should you use Axon? And then how does Axon work? The first two questions are very concrete and very fun. The last one is going to get into some of the technical details, and if you're a beginner in deep learning, it might get a little dense, and I apologize. This is not a talk on what deep learning is, but I think it'll be interesting for everyone regardless of their experience with deep learning. So the first question, what is Axon? Axon is a library which provides a simple and straightforward interface for using deep learning in Elixir. And there's really two key points of emphasis here. So the first is that Axon is simple and straightforward. The API for Axon is intentionally small, so you can create neural networks and you can learn how to create neural networks in Axon relatively easily, relatively quickly. You don't have to be a math or machine learning expert to use Axon because it kind of abstracts away a lot of the things that are going on. And you can peel back those layers of complexity as you explore the API further. And the second point of emphasis is that this is all just Elixir. I really want to emphasize that Axon is not a NIF, it's not a port, there's no magic, it's just Elixir. It's Elixir code, and so if you want to understand how it works, you can just go to the library and read Elixir like you would any other library. This is an example of Axon source code. So this is literally 20 lines of code to create and train a neural network. And this covers about 99% of the applications you would use Axon for. Like I said, it's relatively small. If you are coming from like PyTorch or TensorFlow, you might actually see the API is relatively similar to those, and that's intentional, and I'll talk about that a little bit later on. Now this kind of begs the question, what is deep learning? And I have a one-slide distillation of what deep learning is, which does not do it justice at all. You can not cover all of this material in even a 2,000-page textbook. But really, neural networks are deep learning is a subset of machine learning based on artificial neural networks. I really don't like the biological analogy because I think it kind of overcomplicates what's happening. Like the brain is really, really complex, and there's no evidence to suggest that what neural networks are doing is exactly the same as what the brain is doing. Realistically, neural networks are it's linear algebra, it's matrix math. There's a popular theory that neural networks are so powerful because they learn hierarchical representations. So a neural network is just a composition of functions. I pass an input through one function and then the next and then the next. And it learns representations of inputs at different levels of abstraction. So if I start with an image of a dog and I pass that in my neural network, then the first layer might extract the features which represent an edge of that dog. And then the next layer, the next function might extract the features that represent the eyes of the dog. And as you pass this through subsequent layers of abstraction or subsequent higher level representations, you can then assign a label or a value to whatever your input is. So realistically, all neural networks are functions. And you'll see right here, this is what a neural network looks like in NX. It's just an Elixir function. You have some learned parameters. You pass it through some transformations. But at the end of the day, it's just a function. And this kind of begs the question, why do I need Axon if I have NX? If I can do all of these things in NX, then why would I bother to even use Axon? And realistically, you don't have to choose to use Axon. Axon compiles down to NX, it builds on top of NX, and it kind of saves a lot of the boilerplate that you would need to train, create, initialize neural networks. The relationship between Axon and NX is probably pretty similar to the relationship between like Cowboy and Phoenix. So Phoenix operates at a much higher level of abstraction, as does Axon. I hope that reference was correct because I'm not much of a web developer, so I'm not even sure if that's the right thing to say, but I hope that landed. Now we move on to what deep learning can do. So this is actually a picture of my dog, Weston. He likes to steal bananas. This is a golden retriever, right? Everyone in this room knows that this is a dog, that this is a golden retriever. But if I ask you why it's a golden retriever, can you tell me why it's a golden retriever? Can you describe to a machine why this is a golden retriever? Is there a formal set of logic that I can use to describe the set of all things that are golden retrievers? And it's these seemingly simple problems that are layered in complexity that neural networks are actually really, really good at solving. So I have here a screen. Oh, sorry. My girlfriend forced me to include his Instagram in order to use this picture. So if you want to follow Weston on Instagram, please be my guest. This is a screenshot of an Elixir script that we can use to classify that image of the dog. And I totally understand the irony of me including redacted code in my presentation. This actually uses a library that hasn't been released yet, and I don't want to be the one to spoil the surprise, but I promise this is a regular Elixir library that all of you will be able to use sometime within the next month, so be on the lookout for an exciting announcement. But you can see this is just NX, EXLA, Axon under the hood. This is 100% Elixir, and now I have this quick GIF here where I'm just passing my Elixir script, that dog, picture of my dog, and you can see it spits out eventually, and there's a golden retriever. And this is really cool. We can do a lot of really interesting things with this, but we can also do more advanced things. So I have another GIF here of a script I'm running, and I type in, I love Elixir, and I wait for an output. And it translates it to Romanian. So does anybody here speak Romanian? I don't speak Romanian, so I checked that this was correct with Google Translate, which ironically also is a deep learning model under the hood, and so I used a deep learning model to check the output of my deep learning model. This is the script, and it's even more redacted because it makes even more use of that library that will be released in the future, I promise. I apologize again for the redactions, but I didn't want to spoil the surprise for anybody. One of the other neat things you can do with Axon is not just inference. So you can work end-to-end in Elixir for your entire machine learning workflow. So you can train a model, you can deploy a model, you can orchestrate models in production. Really, you can work entirely in Elixir. You don't need Python or any other stack or language to do anything. You can do everything within Axon. So this is an example of me training a neural network on MNIST with Axon. There's a lot of these examples in the Axon repository, and people are contributing more and more every day. So if you want to dive into neural networks, I highly encourage you to submit an example, a training script or inference script, and I'll be happy to review it. And this really just scratches the surface of what is possible with deep learning. So this kind of looks like a little bit of a trippy photo here. Has anybody heard of Stable Diffusion or DALL-E 2? Yeah, so the cool thing is that we can actually do all of the same things you can do with Stable Diffusion in Elixir. So this is an example of an image I generated with a project that I've been working on recently. The prompt for this image was something with like numbats and witches and mixing up elixirs. And it doesn't, while it's not photorealistic, that you can see kind of the Halloween vibe that's coming from it. And this is entirely in Elixir. I truly am a big believer in the fact that we've really just scratched the surface of what's possible with deep learning. I feel like this is kind of like the nascent stages of like a new class of applications that are built around artificial intelligence and models. Dare I say, the real Web3. Before I gave this talk, I like kept promising myself that I wasn't going to say anything too controversial, so I hope that wasn't too controversial of a meme to include in my talk. So now we have to answer the question, why Axon? You know what deep learning is, and it makes sense why you would use it, but why would you use Axon? And there are really a few benefits to Axon. And honestly, I get this question a lot too. People always come ask me, you know, why did you make a deep learning framework in Elixir when we have PyTorch and TensorFlow? And the short answer is because I felt like it. But the long answer is I think there's some serious benefits to be had by using a deep learning framework in Elixir. And that first point there, Axon provides a runtime agnostic, pure Elixir interface for deep learning applications which can scale up or down to meet your needs. So we all were in the keynote this morning where Brian introduced LiveView Native. And it's interesting because Elixir as a language is capable of targeting so many diverse deployment environments with Nerves, LiveView Native, Elixir Desktop, server deployments with Phoenix. And Axon is the same way as a consequence of how NX was designed. So NX supports pluggable backends and compilers, which are basically just runtimes for accelerated matrix math. So I can choose to use Axon. I can use Axon as an interface for performing deep learning, and then I can change my runtime based on what my deployment target is. So if I have an application that I want to use deep learning for and I want to deploy it on an iOS device, then I can choose to use an accelerator or a runtime that targets an iOS accelerator. And I don't have to change the code that I use to the front end, the Axon interface that I used to interact with that, because everything's happening behind the scenes. Another common complaint against Axon I hear is that it's impossible to keep up with the pace of innovation in deep learning because it really is, it's expanding rapidly. I go on Twitter and every morning there's a new model that I have to implement. I have to see if it works in Axon. And at times it can get tiring. But realistically, the way we've designed Axon is to be as maintainable as possible, and I'll talk about that a little bit later on in the talk. And as a consequence of that, Axon is really on par with or catching up to TensorFlow and PyTorch in a lot of areas. So there are still some limitations that things you can't do in Axon, but they're on the roadmap and they're not out of the realm of possible. Now I like to divide the groups of people who would choose to use Axon into 4 different camps. The first one, I'm an Elixir developer and I have a machine learning need. Why would I use Axon? So you'll hear a little bit about this tomorrow in Chris Granger's keynote. I don't want to steal his thunder. But using Axon, if you already have an Elixir stack, allows you to avoid framework fragmentation. So you don't need to plug in with you have a team of data scientists working entirely in Python, and you have a team that's building your app in Elixir, and it's difficult to kind of meet in the middle. It's difficult to glue those teams together. If you're working in Elixir from the start, then you don't have to worry about doing that. If you're an Elixir developer but you don't have a machine learning need, I'm not encouraging you to go out and seek a machine learning need because I really don't like when people just attach the machine learning buzzword to an application. So by no means should you go out and seek a machine learning need, but I am of the opinion that machine learning is getting so powerful that it makes more sense to, or there's so many things that you can do that can benefit from machine learning. And if you're an Elixir developer and you find a machine learning need, then it just makes sense to start with Elixir. Now this is where things start to get a little bit difficult. So you're not an Elixir developer and you have a machine learning need. More than likely you're working in Python or R, maybe some Scala. So why would you make the switch? And I can understand the cost of switching can be relatively high. But one of the things that we've emphasized with Axon is portability. So in Axon, you can import models from TensorFlow and PyTorch almost seamlessly with Axon O and NX and some of the other projects we're working on. And so that cost of switching is lowered as a result. Another thing, too, is that, like I said before, Axon offers a unified inference interface at all scales. And I think that's a benefit that might be too compelling for some people to pass up. And now the final people are the people that don't have, they're not an Elixir developer and they don't have a machine learning need, so why would you use Axon? The good news here is there's actually no cost of switching. There's no friction for you to switch from Python to whatever. And so it's easy for you to start in Elixir and then continue with Elixir. Finally, I think there is a lot of things that the Elixir community can contribute to every cycle or every stage of the machine learning life cycle. Machine learning ops is a really challenging problem. It's an open problem. People going from, a model going from a notebook to production is something that really hasn't been reasonably solved. And I think there are a lot of people that can contribute. I think there's a lot of ideas that the Elixir community can offer to the machine learning community. I unfortunately came up with machine learning the Pythonic way, and I would love to see this community contribute to machine learning the Elixir way and contribute to some of the problems in MLOps the OTP way. So now we've covered the first two questions. What is Axon? Why would you use Axon? And now we're going to go into the technical portion of the talk, which is how is Axon designed? There are 4 principles I tried to emphasize when designing Axon. The first is a simple, straightforward, and familiar API. So when I was thinking about what the Axon API should look like, part of me was ready to just throw out everything I knew about deep learning and design a framework that was so Elixir specific, like took advantage of every possible Elixir magic that I knew. But then I realized that was a bad idea for a couple reasons. So first, if you are a data scientist who's worked in PyTorch and TensorFlow, then you don't want to have to learn a new framework that is so radically different from what you've already seen that it doesn't make sense, right? So Axon should feel familiar to PyTorch and TensorFlow. You saw some of the examples I had before, and if you're familiar with PyTorch and TensorFlow, it really is intentionally designed to kind of match one-to-one with some of the layers there. I've made some deviations where it makes sense, but for the most part, it is really, really familiar. And then the second reason is if you're a beginner, there's just too many tutorials out there on Python and how to do things in Python with TensorFlow and PyTorch that it just makes sense for you as a beginner to seek out those materials and then translate them to Elixir. So you can really make use of all the materials that are already out there, but just apply them with Axon. The second principle is that opt-in is better than opt-out. And this is really a consequence kind of how NX was designed as well. So Axon is really a compartmentalized framework. You don't have to use every single part of Axon if you don't want to. So Axon has a training API, it has an inference API, it has a low-level API. And if you want to use, whatever, you can use whatever you want without opting into using everything else. The third is that explicit is better than implicit, and this is also kind of a consequence of Elixir's functional nature. I have some examples of PyTorch code, and it really is implicit in a lot of ways, and we really can't hide a lot of the things that are going on with Elixir. And so as a result, Axon is a little bit more verbose, but I think for beginners, it kind of captures what's going on under the hood. And then the fourth and probably most important point is that Axon has to be portable. There's just too much work that's been done in the Python ecosystem to start from scratch. So as a consequence, we really needed a way to be able to import models directly from Python or PyTorch and TensorFlow into Axon, and that kind of reflects in how Axon was designed. So there are 5 parts to the Axon API or to the Axon library. There's the actual low-level implementations, which are the meat of the library, and then there's model creation, model lowering, optimization, training, and evaluation. I'll cover all of these in depth. All of these can probably be encapsulated in a talk of their own, so I apologize if I go through this a little quickly, but I don't want to run out of time. So the low-level implementations are really the NX-based functional API. So if you're familiar with a framework like PyTorch and TensorFlow, they kind of have to rely on a very fragmented like C++ and Python mixed code base. And this would be, the low-level implementations would be equivalent to what you would find be the C++ implementations in a framework like PyTorch or TensorFlow. Because of how NX is designed, that we don't actually need to worry about that. So we can implement everything entirely in Elixir, as you see here. And this is really all of everything in Axon boils down to is just a def-n. So everything you do in Axon is just a def-n. It compiles down to a def-n. It works like a def-n. And this is really, really, really maintainable. Most of the Axon functionality, the low-level functionality, I finished in about 2 weeks. And that is nothing to do with me and everything to do with the fact that NX and Elixir are just really productive to work in. And if you contrast this with what a PyTorch low-level implementation looks like, this is not very maintainable for someone like me who's not very good at C++. And it honestly took me like 35 minutes yesterday to find this in the PyTorch repo. I don't really have much experience with the framework, so this isn't a grift on PyTorch. Like, the people working in the Python ecosystem are some of the smartest people in the world. But really, like how Axon is designed allows us to kind of punch above our weight. So Axon is very maintainable. We can rapidly add features without having to worry about how they're optimized under the hood, because we can rely on NX compilers and backends. So now model creation. Model creation is really just the way I'm describing how I get an Elixir model, or I get an Axon model. And you can see the bold words here is that models in Axon are just Elixir data structures, basically. Everything centers around this Axon struct. So this is an example of a built model in Axon. It's just a struct. It's got some metadata. It has some inputs, some trainable parameters. But realistically, this is just an Elixir data structure. So I can work with this in Elixir. I can manipulate it in Elixir. There's no magic. There's nothing going on behind the scenes that we're hiding from you. Layers in Axon are just Elixir functions. So one of the things that I was considering when designing the framework was to take like a behavior-based approach. So if you're familiar with PyTorch, every single layer is an NN module, and then you have to implement an initialization and a forward function. And I thought that it might be wise to go with a similar route, but then I kind of felt like I was forcing a pattern onto Axon that didn't necessarily make sense in the framework of Elixir. So layers in Axon are just an interface and an implementation, and they're just Elixir functions. It should be really similar. It should feel really similar to using kernel apply. You can see I have an example of a layer here. I have an implementation that's defn, and then I just wrap that in some Elixir interface. And I can write Elixir. I can parse options. I can do whatever I want. Everything is just Elixir. One of the other cool things you can do, like I said, is that because this is just an Elixir data structure, you can manipulate models really easily. So if you know how to traverse the graph-like data structure, then you can traverse the data structure. So this is an example of one of the built-in Axon graph manipulation functions that just traverses the graph in a breadth-first order, and then it applies that function to each of the nodes in the graph. It's very similar, if you're familiar in the Python ecosystem, with TorchFX, which is just graph transformations. And it allows you to do some really neat things without having to go outside of the framework. Model lowering. So if you're a compiler person, I don't know if I'm necessarily using lowering in the correct way here, but what I'm referring to as lowering is just taking that Axon struct and turning it into something useful. So this is done explicitly in 3 ways, and you can do this or build on top of this concept yourself as well. Axon has execution, inspection, and conversion. So I can take that Axon struct and I can execute it. I can build it into something that's useful. Axon.build converts the Axon struct into actual JITable NX functions, initialization and predict functions. And these are what actually are used under the hood to get predictions from your model. So after I build up my Axon struct, I call Axon build. Now I have an initialization function which will initialize the model, and I have a predict function that I can use to actually get inferences from the model. We also do this for inspection. So if I traverse the graph, and I can build a tabular representation of the graph. And this is also the same thing that we do under the hood to convert models from Axon to O and NX. So the Axon struct really provides a very convenient intermediary between what you're trying to do, and you can honestly use Axon use the Axon struct as kind of like a universal model for what a neural network looks like. Some of the things I'm really looking forward to with inspection is tighter integration with Livebook. So one of the open issues in Axon, if anybody wants to tackle it, is converting the Axon model to a mermaid graph, which is basically just like an AST representation or a graph representation of what a model looks like. So the next portion of the API to talk about is optimization. Neural networks are typically trained with gradient-based optimization. Really, all that means is I get a prediction, and then I see how wrong my prediction is, and I move a small step in the direction of what's correct. I like to compare it to range finding in the ocean. So if I am on a boat and I have a depth finder and I want to find the deepest point in the ocean, but I don't have a map, then what you can do is you can sort of make these small steps where you know you're descending down towards the deeper points in the ocean. And that's really how gradient descent works in practice. So the optimization API implements a bunch of these composable updates. Composable gradient transformations are what I call them. It's a little technical, but it's modeled directly after the Optax library, which is a library from DeepMind. And that library is genius. One of the things this allows us to do is it makes our optimizers very testable and very maintainable. So we decompose every single update or every single step of an optimizer into very small chunks. So you can see here, these are the actual implementations of optimizers in Axon. They're very small, they're very composable, they're very easy to test. And this is another point here that we can really rapidly iterate, rapidly research, and rapidly try new things just by building up a very composable and maintainable API. The final portion of Axon's API is the training and evaluation API. Really, this doesn't actually just touch training and evaluation. The Axon loop module is very general. I call it instrumented reductions over Elixir streams, which really just means we're using reduce while under the hood. It's something that's really, really general. So when you think about what training is in the sense of a neural network, you start with a set of parameters, and you slowly update them until you get to a set of parameters that does whatever you want to do or accomplishes whatever you want to accomplish. In frameworks like PyTorch and TensorFlow, you can model this relatively easily by just like with mutability. In Elixir, we have to model this as a reduction. And so that's what we do. It's really, really flexible. You don't have to just apply this to neural networks. I haven't found a concrete use case outside of neural networks, but if anyone finds one, please let me know. I have plans to abstract this out to a separate library, so I'd love to hear what people come up with. This is an example of what an Axon training loop looks like. So I have a factory function. I pass a loss and an optimizer, and that builds basically initialization and step functions for me. So the Axon loop is actually another data structure. We kind of went the data structure route for everything with Axon because it makes things a little bit easier. So that trainer function actually creates a new loop data structure for me, and that implements the initialization and step functions for this loop. And now when I pass that to run knows how to take that loop data structure and execute it in practice. So my data is just an Elixir stream, and then I pass in some initial state, and that's going to run through the loop for 10 epochs for me. And you can see this is, like I said, it's just Elixir. It's not a large amount of code. Nothing you do with Axon will require a lot of code because we've tried to make it as, I would say, simple and straightforward as possible. Another thing you can do is evaluate. So I can instrument a loop with metrics, and this is metrics in the sense of what you would like use machine learning for. So in this case, I'm instrumenting this loop. I'm tracking the accuracy of my model. But it doesn't have to necessarily apply to whatever machine learning is. So if for whatever reason you want to count things that are happening in the loop, you can use metrics to do that. Another thing you can do is instrument. So I can attach event handlers to the loop. So at every step in the loop, there is an event that fires. Every time an iteration completes in the loop, an event fires. Every time an epoch completes in the loop, an event fires. Every time the loop starts, an event fires. And you can instrument this and do some really, really cool things. Especially with Livebook. So one of the things I've seen in practice is that you can actually implement like dynamic plotting of loss functions in Livebook. And in many ways, this eliminates a lot of the need for experiment tracking libraries like TensorBoard and some of the other things that exist in the Python ecosystem. I have a lot of people that ask me, like, do you plan on integrating with weights and biases or TensorBoard or anything? And I'm a little hesitant to do that because I want to see us expand what's possible with Livebook before I decide to latch on to something that's already existing. There are some limitations of Axon, as I mentioned before. Some of these are showstoppers for some people that are choosing to use machine learning in practice. The first one is distributed training. So this is planned. Distributed training is really just distribution across accelerators and nodes. And for everyone listening now, I'm sure that's very obvious that Erlang is very good at that. Elixir is very good at distribution. So it is in the works, but it hasn't been implemented yet. Mixed precision training, this is another thing that allows you basically to train a model on smaller devices or smaller accelerators with less memory. This is partially implemented, but there are some portions of it that just won't work correctly in practice. And finally is model serialization. So serialization is when I take an Elixir or Axon model and I convert it to something that I can store on disk. Under the hood, it actually uses term to binary. And if you have a custom function or a custom layer in your model, then it's not going to serialize correctly because you can't use binary to term to serialize anonymous functions between different processes. So if anybody has a good solution to that, I'm open to hearing. Please see me after this. And then our future plans. Tighter Livebook integration for sure. So I forget who it was gave the talk on smart cells, but if you attended that talk, I would love to see some really awesome Axon smart cells that make it easier for people to use deep learning in Elixir. And then an Axon serving solution. So there are a lot of interesting considerations you need to have when you're deploying a model to production. And a lot of the considerations are things that are baked into Elixir and OTP. And I would love to see like a native Axon serving solution rather than something like TensorFlow serving or PyTorch serving or something else. And contributions are welcome for all. We have a very extensive issue tracker, so if you're looking to get started with Axon, it's always a good idea to contribute, and I'd be happy to mentor you through the process. These are just some fun things to explore, especially with Elixir OTP. Fault-tolerant training. I'm not sure if anybody's ever read the OPT 176 logbook from Facebook. Basically, they trained a large language model at like massive scale with like 384 GPUs or whatever. And because of hardware failures, they needed to have someone literally on call watching the model train like all the time. So there's some interesting things you can introduce with like fault-tolerant training, so you make sure your training restarts from a good checkpoint. And I think there's some things we can explore with Erlang and OTP and Elixir. Another one is hot model training and serving reloads. I'm honestly not sure if this would even work in practice, but there is an interesting paper from OpenAI where they talk about doing hot model reloads on a Dota 2 model. So I think that would be something interesting to explore. The next one, there's a really, really good series of blog posts by Shreya Shankar about the model monitoring mess. So monitoring for model drift or making sure your models are still accurate in production is really, really challenging. And since one of the strengths of Elixir, Erlang, and OTP is observability, I think there are some things that we as a community can contribute to resolving that monitoring mess. And then finally is some fun domain-specific languages for creating neural networks. I originally implemented Axon with a DSL, and then I realized that was like a bad idea from the start, but I still am interested to see if there's some unique APIs that people can come up with. That concludes my talk.